Welcome back, everybody. Today we're moving on in our chapter on logical reasoning. We're going to do section 2-2, conditional statements. Objective today to recognize conditional statements and write the converse, inverse, and contrapositive. We'll explain all that as we go here. Alright, so first off, what is a conditional statement? I'm going to say a conditional is an if-then statement. So as in, if you do your homework, then you can go to the movies. Okay, an if-then statement. And we can break a conditional down into two parts, the hypothesis and the conclusion. I'm going to say the hypothesis is the part following the if. So again, if you can do your homework, then you go to the movies. The hypothesis be you do your homework. And the conclusion is the end of the sentence after the then. So in the case of if you do your homework, then you can go to the movies. The go to the movies would be your conclusion. Okay, we can make a conditional statement look very mathematical if we want to. We won't go there much in this class, but I can write it out with symbols, P arrow Q. I'd read this as if P, then Q, where P and Q can stand for variables as in parts of sentences, just like we do with numbers and X's, Y's, and Z's. Okay, I can also diagram a conditional out with a Venn diagram where P is the smaller circle, Q is the larger circle. Okay, so again, we look at this as if P, then Q. Okay, my movie example isn't great for this one, but we'll look at some examples that make sense as we go to Venn diagram. So first thing I want to do today is look at some conditionals, look at some examples, and split them apart into their hypothesis and conclusions. Okay, so problem 1 part A says, what are the hypothesis and conclusion of the conditional? We have the conditional, if an animal is a robin, then the animal is a bird. Okay, the hypothesis is just what's between the if and the then. So that'd be an animal is a robin. And then the conclusion is just everything after the then, so that would be the animal's a bird. Okay, so hypothesis between the if and the then, conclusion after the then. Okay, real quick with this one, it doesn't say to do it, but this is a good example for our Venn diagram. If I make a larger circle to represent birds, and make a smaller circle within that for robins, okay, that makes sense. Robins are a type of bird. And I could read this Venn diagram as if an animal is a robin, then we know it's also a bird. All right, B is the same idea. What are the hypothesis and conclusion of the conditional? If a number is even, then it's divisible by 2. Okay, well, again, the hypothesis would just be a number is even. And conclusion would be it is divisible by 2. Okay, pretty simple, but it's important we can split these sentences into these parts, hypothesis and conclusion, for the stuff we're going to do next. The next thing we're going to look at doing is taking normal, everyday language and turning it into a conditional, an if-then statement. As you're having conversations or as you're writing papers, you're probably not using a lot of if-then statements. Okay, they're not all that natural to us. But it's going to be very important that we can take our language, take our ideas, and communicate them in if-then form, okay, because the conditionals are going to be what allows us to chain logic together and come up with new geometric properties, formulas, theorems, and that kind of stuff. Also, if you're looking to do any computer programming, okay, computers run based on conditionals, if something, then something else. So it's again important you can take your ideas or what you want the computer to do and turn it into a if-then statement. Okay, so let's do that here. Part A says, how can you write the following statement as a conditional? And our normal language statement would be vertical angles share a vertex. The first step to this is going to be deciding what the hypothesis and what the conclusion are going to be. So what two things are we talking about here? Okay, I'm going to say I can break this sentence up into vertical angles, kind of the subject, and then the property sharing a vertex. So the way I'd write this as a conditional is I'd say if angles are vertical angles, okay, so if angles are vertical angles, then we can just say they share a vertex. Okay, so if angles are vertical angles, then they share a vertex. Okay, notice here I had to talk about what the they is in the beginning of the sentence, angles, then I can say they. Okay, I want you to do this. I want you to pause the video for a minute. I want you to try to do the same thing with the statement dolphins are mammals, and then hit play and kind of check your answer. All right, same idea. Dolphins are mammals. Two things happening here. We're talking about dolphins. We're talking about mammals. So we can say if, and we need to say something about dolphins. We can just say an animal is a dolphin. Then, all right, it is a mammal. So next thing we're going to talk about is the idea of a truth value. Now, the reason conditional statements are helpful in math, in computer programming, in applications where we need very precise language, is they have a truth value that's always either true or false. Okay, so conditional is always true or false. It's never maybe true, sometimes true, sort of true. It's always true or false. So next thing we're going to do is look at finding truth values for conditionals. So problem 3 says, is the conditional true or false? If it's false, find a counterexample. Okay, so for part A it asks, if a woman is a Hungarian, then she is European. Okay, in other words, this will be true if Hungary is in Europe, and yes it is. Okay, so if you're from Hungary, you're also from Europe. So we'll say this statement is true. All right, B, we have the conditional. If a number is divisible by 3, then it is odd. All right, I'm going to say this statement is false. Not every number that's divisible by 3 is odd. There's some other examples. So as a counterexample, I could say 6. And 6 is a good counterexample because it is divisible by 3. In other words, we could say it satisfies the hypothesis, but it is not odd. It does not match my conclusion. Okay, so basically a counterexample to this claim would be any number that's divisible by 3, but not odd. Any number that satisfies the hypothesis, we can't make the conclusion about. All right, C, same idea. If a month has 31 days, then it's August. Okay, this is false as well. Okay, August does have 31 days, but there's other months with 31 days. So, for example, October. Okay, October 31st, which is Halloween. October has 31 days, but it is not August. Okay, therefore we can make that counterexample. All right, last one here. Get my face out of the way quick. If two angles form a linear pair, then they're supplementary. Okay, a reminder what a linear pair is are, let's do that right here, two angles that when I put them together, they form a straight line. Okay, they make a straight angle. Now, since a straight angle is always going to sum to 180 degrees, yes, this would be true. That linear pair is always going to make 180 because a straight angle is always 180. Okay, so this one would be true as well. The last thing we're going to talk about are some different ways to rearrange a conditional statement. So we've got our conditional, our if-then statement, and then I have three ways to rearrange it. First one is the converse. Okay, converse is going to exchange the hypothesis and conclusion of a conditional. So in other words, reverse the order of that statement. If we go back to our original, if you do your homework, then you can go to the movies. The converse of that would be, if you can go to the movies, then you did your homework. Okay, inverse is going to negate both the hypothesis and conclusion. So again, negate means just basically adding not to the hypothesis and conclusion. So in the case of if you did your homework, then you can go to the movies. Negating that would be if you don't or do not do your homework, then you cannot go to the movies. Okay, then last one's contrapositive, which negates both the hypothesis and conclusion of the converse. In other words, with the contrapositive, we're going to flip it like the converse and negate it like the inverse. So again, in the case of if you do your homework, then you can go to the movies. That would be if you cannot go to the movies, then you did not do your homework. All right, then this is going to lead to the idea of equivalent statements. I'm going to say that statements are equivalent if they have the same truth value. So if either they're both true or both false, we'll call them equivalent to each other. All right, so problem 4, part A says, what are the converse, inverse, and contrapositive of the conditional statements below? And then also, what are the truth values of each? If it's false, give a counterexample. So I have a conditional statement. If a figure is a square, then the figure has 4 sides. And I want to rearrange that, which each of the 3 ways I have to rearrange a conditional. Okay, so we'll start off with the converse. Okay, and the converse takes the hypothesis and conclusion and just reverses the order, flips them around. So in this case, I could say if a figure has 4 sides, okay, then the original hypothesis, then the figure is a square. Okay, so just flipping hypothesis and conclusion. If a figure has 4 sides, then the figure is a square. Okay, now is that a true statement? I'd say no, that's false. And a counterexample to that could be a rectangle, because it has 4 sides, satisfies the new hypothesis, but is not a square. Okay, so it doesn't match the conclusion. All right, next up, let's do the inverse. Okay, inverse leaves the conditional in the same order, but negates the hypothesis and conclusion. In other words, adds a not to it. So in this case, we'd say if a figure is not a square, oops. Okay, if a figure is not a square, and again, negation just means add a not, okay, then the figure does not have 4 sides. Pen's messing up here. All right, so if a figure is not a square, then the figure does not have 4 sides. Okay, truth value, again, this will be false. Okay, because again, a rectangle is not a square, but it does have 4 sides. So no, that doesn't work. Okay, then the last one we have is the contrapositive. Geez, my E's are messing me up here for some reason. Okay, and that one both flips the hypothesis and conclusion and negates them. So let me get myself out of the way here quick. And we'd write that as if a figure does not have four sides, okay, then the figure is not a square. All right, so again, contrapositive, flip them and negate them. Now, as far as the truth value goes, this will be true. Okay, if a figure does not have four sides, it can't be a square. Squares have four sides, therefore that one's true. All right, a lot of writing, but not that tough. Part B is the same idea. Why don't you pause the video quick, work through that one on your own, and then I will show the answers to check and make sure you're doing things correctly. All right, so problem B, if you're a quarterback, then you play football. Okay, here's the answers. Here's our converse, inverse, and contrapositive. Converse, again, flipping the order of the hypothesis conclusion. If you play football, then you're a QB. Okay, now that's false because a running back plays football, but it's not the QB. Inverse, we just negate both hypothesis and conclusion of the original conditional. If you're not a QB, then you do not play football. Okay, again, that's false because a running back is not a QB, but it does play football. And then finally, the contrapositive, where you flip the order and negate. So that would be if you do not play football, then you're not the QB. That is true. Okay, to be the QB, you have to play football. So that's a true statement. Now, if you notice in the last problem as well, the contrapositive was true along with the true conditional. Okay, the converse and inverse are sometimes equivalent to the conditional, sometimes they aren't. But the trick here is that the contrapositive is always going to be equivalent to the conditional. All right, there you go. That's section 2-2, conditional statements. Start cranking out some homework. Let us know if you get stuck with this stuff.